In section 3B, we're going to look at composition of functions. Okay, so when there was a dot, it was multiplication, but now you're going to see the notation here where we have this kind of little open circle in the middle. So when you see f and then this open circle, that means f of g. Okay, so that would be equivalent to f of g. It means you're going to put g into f. So put g into f. So you start with g and g goes into f. It's one function composed of the other. So this really means f of g of n. So g is going in to function f. You're kind of working right to left, kind of backwards from what you think. So what I'm going to do is I'm going to take function g, which is n squared plus 4, and it's going to go into the variable in function f. So f of g, I'm going to have 2, and then in for that n, we're going to put n squared plus 4, which is a binomial, so I'm going to put it in parentheses, minus 1. And now we distribute, so it's 2n squared plus 8 minus 1. And we simplify so we can combine those. So it's 2n squared plus 7. Now let's do 23, because you can compose a function of itself. So this right down here means I want h of n. So I'm going to put function h into itself. So I am really going to go, function h is 2n minus 4. So I'm going to then look at this n, and I'm going to put 2n minus 4 in there. You're putting a function within its own function. So if I put 2n minus 4 in there and I distribute, I'll get 4n minus 8 minus 4. I can combine like terms. So that's 4n minus 12, and we don't want to factor out the 4, just leave it in non-factored form. So that's h of h, and that can be sometimes what you're doing, you're putting a function into itself. Key thing is, when you have two different functions with different letters, take the right one into the left one. Don't do them backwards.